So router 7, let's confirm that we can ping our neighbors. We can ping router 5. Can router 7 ping router 6? 4.1.6.1. Yes, it can. So router BGP, in this case autonomous system 20, neighbor 8.1.5.1, remote AS is going to be 8. That's the autonomous system of router 5. And then we need to configure a neighbor relationship to router 6 in autonomous system 4. So neighbor 4.1.6.1, remote AS 4. Once again, in eBGP, you form neighbor relationships typically to the directly connected IP address of the neighbor. We are not using loopback IP addresses which you would use in iBGP. eBGP, we're going to use the physical IP address of the neighboring router. While we're here, we'll advertise the loopback and advertise the other networks on this router. So 4.1.6.0, show IPBGP. So those three networks now appear in the BGP routing table. Show IPBGP summary. At the moment, the neighbor relationships are active, but remember, active doesn't mean it's working. We need established. So in router 6, show run pipe section BGP. We don't have a neighbor relationship to router 7. We only have a neighbor relationship to router 4. So router BGP 4, neighbor 4.1.6.2, remote AS is 20. On router 5, router BGP 8, neighbor 8.1.5.2, remote AS is 20. On router 7, we can see that the neighbor relationship to both neighbors has come up. So show IPBGP summary. Both neighbor relationships are established. 13 prefixes have been received from both neighbors. Show IPBGP. What you'll notice is that we have two entries for multiple routes in the routing table. Router 7 is learning about 4.1.3.0 from different routers going through different autonomous systems. So as an example, to get to 4.1.3.0, this network, it can either go via autonomous system 4, so directly this way, or it can go via autonomous system 8 and 17, in other words, go via this path. And it's chosen this as the best path because the autonomous system path is shorter. Notice for this network as an example, to go to 4.1.4.0, this network over here, it can either go via autonomous system 8, that autonomous system at the top, then 17, and then 4. In other words, go round like this, or it can go directly to that network through autonomous system 4, and it's chosen to do that because it has the smallest autonomous system path. As an example, if we trace to 4.1.4.1, it goes directly this way. But what about 17.17.17.1? So show IPBGP. Here is 17.17.17.1, and it's chosen, notice the greater than sign, it's chosen to go via this path. Even though the autonomous system path lengths are the same, and I'll just filter that to make it easier to read. So 17.17.17.1, even though the autonomous system paths are the same, it's chosen this path as the best path based on some kind of criteria. And if you go through all the BGP selection options, you'll notice that it prefers the path that comes from the lowest neighbor address. Before that, it will choose the path with the lowest neighbor router ID. So this router ID is lower than this router ID, So this is chosen as the best path. What about on router 1? Show IPBGP. To get to network 20, it's going via Autonomous System 4 and then Autonomous System 20. So once again, it's chosen to take this path. Now when you do the route course, it's part of your CCMP, you'll see why the next hop is actually set to this IP address rather than this IP address. IBGP, in brief, doesn't change attributes or change values. So when this network was advertised through eBGP from router 4 to router 2, and router 2 in turn advertised that to router 1, router 2 did not change the next hop address. So the next hop address remained as router 4, even though that IP address is not directly connected to router 1. BGP works differently to other routing protocols. A next hop doesn't have to be directly connected. But notice you can see the AS path. On router 2, we'll be able to see multiple paths as an example. So show IPBGP. To get to network 20, this router can either use 8.1.1.2, that IP address, or this IP address, 4.1.3.2, and it's decided to use this path, notice the AS path here, to get to the remote network. So in router 1, we can prove that by doing a trace to 2777, and what you'll notice is it hits this IP address, 17.1.1.2, then it goes to 4.1.3.2, then it goes to 4.1.4.2 in Autonomous System 4, and then it hits 4.1.6.2. It is showing the Autonomous System number wrong here, because that's actually Autonomous System number 20. But the egress Autonomous System is 4 that it used to get to router 7. So can we manipulate the paths?